Okay, let's continue with our introduction to database. We're moving on to part 3a, entity relationship diagrams. Right, so what exactly is the ER diagram, right? Okay, so we have this table here, this database that we set up earlier. We have four tables here. We have a student table, we have a civics table, and then let me just highlight some stuff. So the student table, and of course we know that our key is the metric number here, and then civics table, and the key here is our civics class, of course, the primary key I mean, and CCA info table and student CCA table. Right, but so this is useful. This is the full table. But then when it comes to planning, right, it's not so useful to just write out everything first. Okay, we can use what we call an entity relationship diagram to represent the relationships within your database. Okay, so we see how to do that next. Right. So what exactly is a ER diagram? The first thing to talk about is an entity, right? An entity is a specific object of interest. So they are known as, so usually we are looking for collective nouns or nouns. So for example, you look for terms like, okay, so these are the terms we're looking for, collective nouns or nouns. We're looking for things like student, CCA, customer, etc. Okay, so we represent entity by a rectangle. So once we found an entity, we just write it inside a rectangle, right? Usually we write it in the singular form, right? Okay, so this is the same for all of them, right? So this is your entity. Okay, so let's see a simple example of how we identify entities. Right, usually when we want to design a database, we will ask the client to write down what they want the database to be able to do. Okay, so in this case here, right, we have the school writing this. A school wants a simple application to keep track of their students, their civics class, and the CCA they join. Right, the application must also keep records of all the CCAs in the school, the students joining the CCA, and the civics class assigned to each student. Right, so key thing to do now is to highlight all the nouns. Okay, so I'm just going to circle them. So I'm just going to make it very simple first. I'm just going to highlight everything that's a noun. Right, so this is school, a simple application, keep track of the students, civics class, and CCA. This application, CCAs in the school, students, CCAs, civics class, assign each student. Right, so if we sort through the nouns, right, we can see that there's 5 of them: school, application, student, civics class, and CCA. Right, so we can rule out some of the things first. The first one we can rule out is because we can rule out CCA. Okay, we can rule out school. Okay, we can rule out school because, right, there's no data to keep track of. Right, the school is just the school. So for example, let's say you do YJC wants to do a simple application here, right? You just need to know there's YJC, right? It's not important to keep track of it all the time, right? Application here is like saying the database is the app. It's an app to do all this record tracking. So it's not so important. So in this case, right, you have 3 terms that keep on coming up. You have your students, you have your civics class, and your CCA. These are three terms that keep on coming up. Okay, so these are 3 nouns. So this will form your entities. All right. Okay. Next, we have learned how to identify entities. Usually they are nouns. They're useful nouns that we find, and then they can form an entity, right? But between entities, right, there has to be relationships being formed, right? Otherwise, you cannot have your database. So we're looking at 3 types of relationships that can exist between 2 entities. Okay, they are one-to-one, one-to-many, and many-to-many. Okay, the next few slides we'll see how what all these things are about. Alright, so first one, we have this one-to-one relationship. So a one-to-one relationship, right? You basically, when you join the entity, right? You just draw it with a straight line, right? So it's just a line. There's no multiple connections, as you can see later. Okay, so one-to-one connection is that when the first entity on the left-hand side, okay, every single occurrence of it maps exactly to one other occurrence on the other entity. So for example, say if you go to attend you bought tickets for a show, all right, and then your ticket only allows you to sit at a particular seat, all right, so that particular seat is only assigned to your ticket, right? So this is a one-to-one relationship, okay, between ticket and the concert hall seat, right, or the ticket and the cinema seat, right? So you can, if you think carefully here, there are also other possible one-to-one relationships. Okay, so let's look at some other examples. Right, we have person and NRIC number. So in the context of Singapore and probably most countries in the world, right, once a person is given citizenship or residency or born in the country, right, he'll be given an IC number or an identification number. So every person, so let's say person A and person B and person C, all of them will be mapped to their own NRIC number. NRIC of A, NRIC of B, NRIC of C. Okay, so it doesn't overlap. When we look at one IC number, let's say NRIC number A, right, it can only point to person A. Okay, if you're looking at NRIC B, right, it can only point to NRIC number of B. Okay, table and student. Okay, especially now when we are talking about COVID, right? Your SMM measures in the classroom, right? Every student is assigned to a table. Every table can only have one student, right? So this is what you know. Okay, manager and a team. Okay, so this is like in every team there is one position of manager. Every manager can only be in charge of one team, right? So this is a one-to-one relationship as well, right? Moving on, we're gonna look at one-to-many relationship. Okay, so one-to-many, right? We're gonna represent it as, you can see that this special connection here, right? The way to draw this again is like a crow's feet. Okay, so basically if you draw it this way, if I draw it here, and then if I just extend it out, all right, I just draw it like a normal, let's say entity A and entity B, right? I just join it this way. I just draw crow's feet like that. Okay, so this means that A to B has a one-to-many relationship. Okay, so what exactly is a one-to-many relationship? Okay, let's just give you one example here. So for example, in the case of a civics class, right, a civics class can be linked to many students, okay, because there are students from student number 1 to student number 20 in the civics class, okay, but many students can belong to one civics class, okay, so it's a one-to-many relationship. All right, so you cannot have one student belonging to two civics class. It can't be done that way, right? So this is the nature of your setup here, all right. Okay, we're gonna look at more examples again. The next slide over here. Right, so it's a one-to-many relationship. Okay, teacher and the class. A teacher can be teaching many physics classes, but each physics class can only have one teacher, right? So that's how I see it. Okay, then if you talk about, let's say, like a financial planner or insurance agent, right? A financial planner can have many clients. Each client has only that one financial planner, right? And the customer and order, right? Let's say you use a website, let's say Shopee or Lazada. You can, as a customer, you can make multiple orders, but every order belongs to only one customer. You cannot have repeat customers. You cannot have more than one customer assigned to an order, all right? Okay, so this is one-to-many, all right? I hope you're okay so far. Okay, next we do many-to-many, all right? So this can be represented by using the crow's feet on both sides. Okay, so once you see like two crow's feet on both sides, this is a many-to-many relationship. Okay, so using the example that you have from just now, a student can join many CCAs, and one CCA can have many students as well. Okay, so if to come up with something else, it could be, let's say, like, for example, you have a product, okay, and then you have order, okay. Okay, a product can be part of many orders. Okay, an order can contain multiple copies of the product. Right. So this is an example of a many-to-many relationship. On the next page, you'll see some more. All right, over here. Okay, so student and tutorial group. Many students can belong to one tutorial group. In one tutorial group, there are many students. All right, worker and a project. A worker can have multiple projects on hand. A project can have multiple workers working on it as well. Okay, just how we mentioned the order and the item. So you can have multiple items in the same order, and then the item can also exist concurrently in multiple orders as well. Right, so this is many-to-many. Okay, so usually, so now it comes some problems with many-to-many. Okay, so when we have many-to-many relationship within the database, right, usually, right, it's indicative that there are transitive dependencies. Okay, so if you want to achieve 3NF for your database, right, you need to try to break down these relationships. Okay, so for example, let's say I have student and CCA is a many-to-many relationships because a CCA can have many students. A student also can join multiple CCAs. All right. So how to resolve this, right? How to change this away from a many-to-many relationship to a one-to-many relationship? Okay, we introduce a link entity. Okay, so this is what is called a link entity. Right, so a link entity is not an entity on its own usually. It's basically to draw a link between two separate entities. All right, so what does this mean? All right, so maybe let's just try to blank out this screen and we can draw something here. Let me try to do this. Okay, let's see. Can I draw here? Let's see. Oh yes, I can. Okay, so let's say you have student detail, right? You have students. Okay, students over here. Then the students have your, of course, you have your matrix and then also your name. Okay, let's just keep it simple. Let's just keep it like that as well. Okay, students has matrix and name. All right, then you have CCA. Okay, CCA will have name. Okay, CCA name, and then we also have maybe CCA teacher. Okay, these are things we have. All right, so this is the many-to-many relationship, right? So we want to break this up. Remember, right now, this currently exists as this. It exists this way. Okay, so this is CCA. Okay, how to break this up is that we create one more table. We call it student CCA. All right. So what we do is that we will create this table to have basically matrix number and CCA. Right, so we just list down. Okay, so for example, let's say student A has two CCAs. Okay, so let's say just say student A with matrix number 01. He has his name is so and so. Let's say just call it John. Okay, and he has two CCAs, right? We can just write 01. Okay, maybe we should write the CCA first. So CCA, let's say we have tennis, and then we have choir. All right, then this teacher is Mr. Tan. This teacher is Mr. Ong. All right. So let's say John is in a member of two CCAs, right? Then what you can do is that we just write 01 tennis, 01 choir. Okay. So this is the link entity here. All right. So this is your link entity. All right. This is what this part here means. All right. Okay. Okay. So let's go on. Okay, we also can use something called entity matrix. Okay, this is useful in discovering all possible relationships between entities. So what I do is that we write out the entities on both axes, so in one column and also one row as well. Alright, so we write it out this way. And then basically this box doesn't need to be filled because this is talking about student, this is talking about civics and civics, right? So there's no need to fill those. Okay, so when you look at the relationship between student and civics, right? Oh, this is belong. A student belongs to a civics class. Alright, and the student joins a CCA. Alright, then in this case, the same thing. A student joins a civics class, belongs to a civics class. A student joins a CCA. Alright, then there's no link between the CCA and civics, so we can so left it blank. Alright, so this can help us to identify the relationships involved lah. Alright, so basically, student joins at least one CCA. One CCA can be joined by many students, so it's a many to many. Student must belong to a civics class. Civics class have many students, so it's one to many relationship. Okay, so this might be useful in helping you to discover the relationships between all the entities. Alright. Okay, so let's look at how we can break this down. Alright, so we have started to draw the ER diagram for all of them. Okay, so right now you see that student to civics class is a one to many relationship over here. And then student and CCA is a many to many relationship, but we need to break it down to a one to many relationship. So a student can have multiple CCAs. He can have multiple entries inside the student CCA table. The CCA information can also exist in multiple entries for the student CCA table. Alright. Okay. So this is how we can break it down. So this is our very simple ER diagram. Okay. So this is how your end result should look. Something like this over here. Alright, this is your end result. Okay. Okay, let's go on. Okay, so again, we can also write it out fully now. Once we have obtained our ER diagram, then we can start to think about what are the various attributes in each table. Of course, we can identify that in the student table, this is the matrix number is a primary key, and then in the civics class table, the primary key is your civics class. Student CCA, the PK is your matrix number, and then CCA information, right? The CCA name is the PK. Okay, of course there are also foreign keys as well. So this one, civics class from student, right, is a foreign key inside. This is over here inside this one as well as a primary key. So civics class is a foreign key, and then CCA name as also exists over here. All right. So this is a foreign key. So this is a FK and this is a FK as well. Okay, lastly, you can watch this video in Cosmology. The link is there, so please go and check it out. So this will also give you another explanation of what we have explained so far. All right. Okay, next you can go, after you're done watching this video, you can go on to the next section. All right, and we can't click this slide. Let's move this forward. Okay, anyway, we are done with part 3A. You can move on to part 3B.